Welcome back. Today we are looking at a new topic that is differentiation 1. And under differentiation 1, we shall strictly start from differentiation from first principle. Differentiation from first principle. We are going to start with the example and we are going to be following the steps. Number 1, differentiate y equals x squared from first principles. So what we're going to do is this. We follow on these steps. The one you can say, let y equals x squared. This is the first equation. Then here we normally use the idea of the small increments or small changes. You can say, taking delta y, comma, delta x as small changes in y and x respectively. So if we take small y and small x and small y as small changes, so you add them to that original equation, it's going to be y plus small change in y equals x plus small change in x, but the whole thing is what? A square. We say that is the second equation. So after reaching that step, then you are supposed to say equation 2 minus 1. Equation 2 minus 1, when we try to deduct, we are getting y plus small change in y minus y, which is x, plus small change in x squared, minus the first one, which is x squared. So what we're going to have here, this one remains as delta y equals, this one you can see here, this one is a difference of two squares, or we can expand it. Can we expand from Pascal's triangle? Expand this one, we are coming out with x squared plus 2, or this one is the same as x plus delta x, again into x plus delta x minus x squared. We go x into the second bracket, which becomes x into x plus delta x into x plus delta x minus x squared. So we go, this becomes x squared plus x delta x plus again x delta x plus delta x squared minus x squared. So this becomes x squared plus 2x delta x plus delta x squared minus x squared. So when we try to can say delta y equals x squared and x squared disappears, so we shall remain with 2x delta x plus delta x squared. But for small changes, when you say a small change times a small change, which is automatically equals to 0. So when you say small change times a small increment in it, you automatically come out with a 0. So we are remaining with delta y, which is equal to 2x, delta x. Since this one is already 0, you can say dividing by delta x on both sides, So 1 divided by delta x, and we see what will come out. We are having delta y over delta x equals 2x delta x out of delta x. You can see the delta x in the right hand side is disappearing. So we are remaining with delta y over delta x, which is equal to 2x. So, but as small x tends to 0, delta y, delta x is approximately equal to dy dx. So what does it become? It becomes dy dx equals 2x. You can say therefore d dx of x squared, we are coming out with 2x. It means they have differentiated it from the first principle. So when you're advancing from first principle, we follow these steps as we have tried to see in the first attempt as it is bringing that. So we are going to also move on to the second example on it. So the second example still goes. Differentiate the following from first principles. Differentiate the following from first principles. Part A, we have x power half. Part B, can just call it root x. Part B, 1 over x squared. Part C, 2x squared plus 3. Part D saying 3 or x squared plus 5x. Part E, 1 over root x. Let's look at the solutions for each of these numbers. So we are going to be following the steps which we have tried to re-echo, and we want to see how do we approach such kind of those ones. So to go differentiate the following from first principles, part A saying root of x. So when we try to start with the solution, we shall say on part A, let y equals root 2x. And when you talk about a root in mathematics, the same as power half, as we just that time we're looking at indices, is the same as y power x power half. This is the first equation. Then again we say taking delta y, comma, delta x as small changes in y and x respectively. So what are we going to have? We are going to have y plus small change in y, which is equal to x plus delta x, the whole thing power a half, and we say this is the second equation. Then from there we shall say equation 2 minus 1. So can we say equation 2 minus 1? What are we going to have? We are going to remain with delta y, which is equal to x plus delta x power half minus x power half. So expanding this, you can say from the binomial theorem, where we could have a plus b power n, which was the same as a power n plus n, a power n minus 2, b power n, you can consult with n minus 1, b power 1, plus n into n minus 1, a power n minus 2, b power 2 over 2 factorial plus other terms up to b power n. So after understanding that phenomenon, we are also going to come out with the same when we're expanding x plus delta x power a half, which is always x power half plus n is already a half, x power half minus 1, you get negative a half. What is our b is already delta x. Then we also say plus, this one becomes a half into negative a half. Then x power, negative a half minus 1, we are getting negative 3 by 2. Then delta x, the whole of it squared out of 2 factorial plus other terms. Now, after coming out with such a kind of expansion for this, we are going to bring the whole of that one into there, and we see what will come out. So we are having delta y, which is equal to x plus delta x. We have plus delta x power half minus x power half. So we are coming out with x power half plus a half x power negative a half delta x plus a half into negative a half x power negative 3 by 2 delta x squared out of 2 factorial. Then we say minus, these ones are plus other terms. Then we say minus, the one which is there is x power a half. So can we try to reduce x power half and x power half? It goes. So I'm remaining with, here I'm going to remain with a half x power negative a half delta x plus, this is negative a quarter, and when you multiply this one becomes negative 1 over 8. Then we say x power negative 3 by 2 delta x squared. But for small changes, delta x squared is approximately equal to 0. So what are we remaining with? We are remaining with, we are going to remain with delta y, remaining with delta y equals a half x power negative a half delta x. The whole of that one is already 0. When you substitute in the whole of that expression, you get a 0. Then you can say dividing by delta x on both sides. So we are having delta y over delta x, which is equal to a half x power negative a half. Then you can say as delta x tends to 0, comma, delta y, delta x is approximately equal to dy dx. So what does it become? It becomes dy dx, which is equal to a half x power negative a half, which is the same as 1 over 2 x power half, which is the same as 1 over 2 root of x. So therefore, d dx of x power negative a half, you are coming out with x power half or root of x, which was given, you're coming out with 1 out of 2 root of x. That's what you can solve such a kind of a number related to that.